Hello, everyone. I'm Tim, and I'm here um, in this talk to talk about stories from the financial services, AI trenches, lessons learned from building AI models in EY. So we we have two things that we want to discuss with you. Basically, this presentation will go through some of the overview of what we do in the financial services, how we build AI models, and what are the challenges and how we've solved them in the financial services space. And then we'll give you some use cases and examples of actual things, actual projects and solutions that we built, and the learnings that we've learned from those projects. So, first of all, AI in financial services, um, the industry. How does an experiment-driven disruptive technology such as AI look like in a highly regulated industry? So, the financial services, the appeal for AI in FS is great because it's ubiquitous. Everybody pays for things. The data is very rich, but that means there's a lot of regulation around it, and we as technologists, it seems like it's going to be challenging because as AI scientists, data scientists, the sooner we get data, the sooner we get to do experiments, right? And that just doesn't work in financial services. That's why you've got all of these regulating bodies. Um, but what we've learned in the past couple of years is that these regulations are actually your friends and not your foes. Because compared to like 2 or 3 years ago, we've had some surveys or asking uh, industry practitioners where they were saying how there's uncertainty in the regulation and how to regulate artificial intelligence in this industry. But we've progressed from there. There are well-written guidelines, very detailed from FCA, from the European Union. So these are those examples, and also the financial services has is well established. We got regulatory bodies auditing best practices. So one of them, ISACA, has this auditing in artificial intelligence guidelines as well, where they've adopted standards in auditing in order to um, ensure the performance of AI models, ensure trust. So in EY, we have leveraged this by coming up with like our AI development lifecycle, and my colleagues in another presentation, we'll be talking about that trust, context, and regulation, how how we ensure trust, how we ensure there's no bias. But basically, I'll just go over it. And in EY, we do this with this AI solution lifecycle, where we have identified like key methodologies in the development of AI, such as business and governance, wherein you ensure that the business purpose is always taken into consideration, that you're building models that are fit for purpose. The data, you have the correct data. After that is the data and processing step, wherein it's a data-driven technology where you review data sources, the profiles, you ensure that there's no bias, and the data is ethically sourced and following um, guidelines and regulations like personally identifiable information has been removed. And next to that is the modeling section, wherein you build you build models, you have proper model selection. Are you using the correct algorithms? And how do we know that we are doing it correctly? So you got the outcome analysis phase, wherein different kinds of metrics apply for specific use cases, for specific machine learning or AI tasks. And of course, more important a very important aspect is at the end is your deployment and monitoring to ensure that the models are performing well, even if data changes, because it's data driven. So data changes either in different ways. We later on we will talk about that further. But this is how we have approached um, the AI development in financial services here in UI. So the next portion would be for my colleague to talk about specific use cases where we have applied AI, and we could share to you some of the learnings that we have from these use cases.
So in the financial industry, you have a lot of data. You have a lot of rich and various kind of data available to you, but it is highly restricted. So we'll look at one of the examples of this rich source of data, and that comes in Know Your Customer, which basically incorporates various kind of identity documents, forms, passports, driving licenses. It could be address proofs, employment history, business addresses, various kind of sources. And one of the main purpose of this is to verify this information with internal data sources or external sources. Uh, and you want to do this repetitive task uh, automatically. And that's a great example where AI can come into picture and can help you automate this process. But to do that, you require a lot of research and development to build these modules and to be able to process this information. But as you can see, this is highly personalized data. There is a lot of red tape around its usage, where this data can be stored, how it can be consumed, and what sort of libraries you can use them, because you want to make sure those are secured libraries. If they are not, there are issues. So let's dig deeper into this KYC example. And one of the examples is on W-9 forms. So these are basically tax forms, and we're looking into automating this process. These documents are handwritten, particularly, so they are prone to a lot of errors. And what happens is people fill up these forms, they go to the customer, and then they would be rejected by for various reasons, and they have to redo that. So it's not a great experience, and this is where AI can really help, where that human errors and all those things could be taken out. But how do we do this, especially if we cannot do R&D? We don't have the resources and the compute or the libraries which we would like to use freely, because we don't know what we're going to use in the start. So we came with the idea of synthesizing this data. So what we did was we took blank W-9 forms, and then we took one state-of-the-art GAN, which can generate different kinds of handwritings. And you can manipulate the settings to, for example, have different kinds of handwritings with different metrics, different kind of slants, whatever you wanted, you could get out of it, which was a very good example for us to start building on top. And once you synthesize this data, it removes all these restrictions around the storage, the compute, infosec. Everything is now removed out of the picture. So once we got this data ready, then we went to the second part, which was, what do we want to do from this? We want to kind of extract where handwriting is, or we want to recognize where handwriting is in the form. And that encapsulates basically taking unstructured data and making it into structured. And what do I mean by that is, for example, if you can look out here, you got a business name. So you want to recognize where business name is, that handwriting, and also tag it. And then after we have tagged this, we would like to extract that image so we can recognize that and digitize that process. But if you look into this recognition module, we had some of, again, out here, very, very state of the art YOLO algorithms which are used for object detection, which are used in self-driving cars. And we also did a bit of pre-trained networks. So our results were very general and really good. And now we come to the last part, which is handwritten recognition. Here we're using some LSTM based architectures, which are again pre-trained on a lot of open source data. So there is a lot of open source data which you can exploit. You can get that information which is already annotated, and you can train your models onto that. So they are again very generic, and you do not have to worry too much about your real data. Once we did that, we looked into what kind of metrics we can kind of work with, because we got to be aware that this information at the end of the day needs to be verified with internal databases. So what we looked into is, okay, how to best get the most out of it. So we looked into getting metrics like character error rate instead of word error rate. Because if there are a few characters missing, or there is been a changes in handwriting and that cannot be recognized, we do not want to reject the form and go back to the customer. Otherwise, the customer is not going to have a great experience. So we thought, okay, we can look into, maybe distancing and things like that, where we could correct those errors, very small, minute errors. Maybe an R is recognized as an A or something of that sort, um, and we can solve that problem. So that way we were able to do this completely in a non-secure environment, but the end product was something which you can then take it and fine tune it onto your real data. As you have new data coming in, you can or you which is already saved, you can retrain your models and fine tune them for your given purpose. Um, and as you can see, so you know, just to summarize what we went through in this example is that the data can be scarce and highly restricted and can include sensitive and personal information. But if we're creative around it and if we think AI, use AI to create new modules and use it with the right resources, then we can overcome this challenge very easily. By one of the examples was synthetic data, and then you can later fine tune. Similarly, software development, DevOps, all those sort of things are great when it comes to software development. But when it comes to AI, you require MLOps because you want to version your models. As you create new models, you want to have them version, you want to have auditing built into it. And all that can be accomplished by MLOps. So that's a very important component out here. Um, and then when one of the other final point I would say is in a lot of these places, to exploit open source data sources, because especially where this problems are these very novel, like forms, this kind of data sets, it's very good to kind of look around into open source because there will be a lot of annotated data on top of which could be built, or including like pre-trained models and stuff. So I hope this gives you a bit of insights into one of the examples, the challenges we faced, and how you can be creative and overcome those challenges. And there's one more example, one great example, which my good friend Tim will talk to you about. So he'll come back in.
Thanks, Mustafa. That was a really good discussion on that use case. So, as Mustafa mentioned, I'm here to talk about another use case, another common um, AI development learning that we've had in our experience, which is for developing multi-jurisdiction models, wherein the question here is how do we develop models when data comes from clients coming from different geographies and they have different legislations and cross-border restrictions? Because, if you got a bank, you got cross-border transactions, these have like different restrictions where data could sit geographically, whether you could mix them up with other jurisdictions. And they have other things like different behaviors wherein you got like different currencies, different buying patterns. So in this example, as I've given the intro earlier, so let's say you have one client, you've got um, models and bespoke models would need to be developed for a specific geography because the data would be different, the behavior would be different. But what we've noticed is that a lot of these, there's a big portion of the model development life cycle, or at least in the development of these models, that are reusable. So maybe 80% would be reusable components. Why? Because you are doing one machine learning task, but it's almost very similar. It just changes with 20%. So let's say you've got common laws and treaties across jurisdictions. That's one. Similar industry trends and treatments on a specific data set or data point. If it's a transaction that you're trying to code or classify, there might be similarities in the different countries and how they treat them. You've got transactional trends. So let's say um, transactions from a certain or data set from a certain industry have similar transactional trends, seasonalities, language models could be shared, common data models as well, like um, they would have like similar columns, similar features. So it's just a matter of like changing and adding additional or some bespoke columns or some bespoke features for a country or for a jurisdiction. Um, Aside from that, you've got regional markets wherein they're sharing um, trends and data across regional market and national markets. So they got like very similar data sets and the problem is very similar. But again, in order to improve and ensure that you've got good and well-performing models for each jurisdiction, there has to be some sort of modification around it, some fine-tuning and tweaking, and that becomes difficult to maintain in the traditional. If there's no automation, if there's no tooling available, it could be time consuming to be developing each model for each country, for each jurisdiction. So this is where we come in, applying in order to apply like multi-jurisdiction models, as you can see from the right tree diagram, where you've got a base model, wherein that's developed. Like it's like you're cloning it for a specific country. You're fine-tuning it for that data set, either by retraining it on a completely new data set, or it could be there could be some incremental learning from that country or jurisdiction or some other seasonal data set as well. And as earlier Mustafa mentioned that in MLOps and in machine learning development, it's important to track and to version these models. And it might be the same code, but the data sets will be different, and it involves a different handling as well. To give you an example of how we've dealt with these multi-jurisdiction models, is that we've implemented an MLOps and AutoML as part of that MLOps framework. It involves an operating model or framework in terms of how we develop models, and it is also supported by a platform because you need um, in order to automate you need to be able to create repeatable pipelines on the left side. So you can see like that part of the AI development lifecycle of data processing and modeling, outcome analysis. You should be able to create pipelines there. And from our experience, that solves like 80% of the time. That allows you to position your resources, especially experts. Their time is valuable, right? So we focus them in developing these pipelines that are reusable on the left side, and then when deploying to multiple jurisdictions, you could trigger these pipelines, repeat them in order to create a bespoke instance of a model, which is on the right side, your deployment and monitoring. So you're serving a trained model for a specific jurisdiction, and it involves these components where you got like model serving pipelines, CI/CD, um, and once you have that trained model, there should be a way that your platform, your infrastructure should be able to support versioning and tracking these, and in serving models, the feedback loop in the monitoring of these models is important. Why? Because as we mentioned earlier, data it's data driven, so models could be fresh or could be stale based on the data. So we have implemented here the drift monitoring module, which basically detects model drift. And a model could drift in two different ways, which is conceptual drift, which, for example, in our examples where we deal a lot with like transactions, so like a change in legislation, a new rule for taxation, something like that. That is a concept drift. And if your model is trained on the old data set that's coming from old legislation, then it's going to be stale. So you should be throwing that out. And there should be a way to detect that drift. And there's another drift scenario, which is called the data drift, wherein the behavior changes. There might be no change in legislation, but the behavior of data just changed. And a good example of this is when we had COVID, and since let's say we're dealing with like transactional data sets, the distribution of data set changes. So now you've got you're skyrocketing in terms of like transactions involving your essential um, products. Let's say you've got your face masks and hand sanitizers. That's gonna have like a drastic skew in the data. And again, if your model trained on a different distribution, then that's going to affect your your model's performance. And so it's not just enough to be able to capture uh, the drift. So you must be able to act on it, either by retraining your model on a new data set. And you again, you don't want to be repeating all the steps in the model development lifecycle because you're just going to change some data sets. So that's where the automated pipelines and automated machine learning could come in, because once you detected the drift, um, you could launch a training pipeline. You get a more fresh uh, model, or you could have like a rollback step wherein there might be an older, more appropriate model you have used, or even online learning. So incremental learning based on the new and additional data sets. You want to have like an increment in order to be able to handle that. And these are like, maybe one client would have models for multiple jurisdictions and countries. So it becomes hard to manually um, maintain these. That's why the MLOps platform is very important. So aside from that, there is also the human in the loop involved. So how we have found that it's very important to put human in the loop in these process, wherein yes, your model could be giving out, you're still your model is still fresh and fit for purpose, but there's like different predictions. You got high confidence predictions, you got low confidence predictions. So for high confidence ones, yeah, you could just pass it and have your application consume it. But there would be those special cases that are low confidence, wherein you feed it back to someone to have them verify it, and then deal with it either with a remediation step to correct the prediction, or even better if you feed it back to the pipeline, to the training pipeline, model build pipeline, and that sort of stuff. So yeah, so this is something that we've learned from dealing with multi-jurisdiction models. To summarize, our learnings, we have found out that, okay, time from technical and business subject matter experts are very valuable. So you want to have you want to place them in key steps of the model development life cycle, so that you're maximizing their time. And in order to do that, maintaining multiple models from different jurisdictions could be challenging as well without the correct combination of an operating model and an end-to-end ML ops platform. And in that case as well, even better if you have an automated ML pipeline that does the auto ML, that does the model building life cycle for you. So other enabling components that we have used and we have found useful for machine learning at scale for multi-jurisdiction models are these: data drift monitoring and machine learning operations tools, reproducible end-to-end ML pipelines in AutoML, transfer learning, as Mustafa earlier mentioned. We could reuse generic data set, it's very powerful because you want to reuse the learning from these models. So transfer learning and model fine tuning is really important. And for cross-border models, you could also there might be restrictions where you couldn't pass data set from one um, jurisdiction to another, but model weights, you could be able to pass model weights and then retrain and fine tune for another jurisdiction. And and finally, leveraging human in the loop with MLOps framework and online learning. So to sum up our talk, I hope you've learned a lot of things from our experience in developing AI for financial services. Key takeaways, I would say, that is that the appeal in AI lies in very rich data, but that becomes a challenge in itself because they're protected, they're sensitive, and that makes it very challenging. But that drives the value as well, and you could do a lot of things, be creative in making solutions around that space of small data or hard to get data. And secondly, scaling up subject matter experts, knowledge, and their experience is important, and we could help do that and develop ML at scale using a very good MLOps framework and tooling to complement it. So that's all for our talk. We're open for questions and hope you have a good conference.